enough for extended periods of observation like laptop computers, or are expensive and not easily available like pocket PCs. As an alternative to these private recording instruments, we propose the use of a new device based on an Arduino board that works in conjunction with a micro SD shield and a liquid crystal display. This device can be used not only for recording behavioral data accurately, but also to produce feedback to the user when the data are entered and to present visual information. Furthermore, with the addition of an SD card, our device can store the data collected within multiple sessions or observation periods in an SD card. This data could be read later in any computer for analysis. Another important aspect of our device is that it is portable enough to be carried in a pocket. First of all, let me explain what the Arduino platform is. Arduino is an open source electronics prototyping platform that allows us to easily program a microcontroller. Programming is done through the USB port with a programming language similar to C. One important advantage of using the Arduino board over other available microcontroller boards is the vast community that uses this platform. This community shares code that can be used for different projects. Other important features of the Arduino board are that because of its size, it is portable enough to be carried in a pocket, and it is both reliable and accurate. This is the Arduino Uno board. This is the microcontroller that functions as a mini computer, in the sense that the program is stored and executed. These are the digital pins that allows recording signals with values of 0 or 1. These are the analog pins which allows recording or sending signals with varying intensity. This is an USB Type-B jack that it is used to communicate the computer with the board for programming the microcontroller. This is the external supply jack. The Arduino board handles voltages ranging from 5 to 20 volts. Therefore, for portable applications, we can use a 9-volt battery. These output voltage pins are important for our device because the shield, the switches, and the liquid crystal display operate with different voltages each. The pins in this row are 2 ground pins, a 5-volt output pin, a 3.3 volt output pin, and a pin that delivers all the voltage applied to the external supply jack. At last, this is the quartz crystal integrated to the board. This crystal allows recording data with an accuracy to the millisecond. Shields are boards that can be plugged on top of the Arduino board, extending its capabilities. For this specific device, we are using a third-party micro SD shield distributed by Sparky. As can be seen, the board has an extended prototyping zone in which we can solder other components. The micro SD shield allows using the Arduino board to write and read data to and from a micro SD card. In our device, we use it to store the data collected within the session or observation periods directly to the micro SD card. This data could be read later in any computer for analysis. Along with the micro SD shield, we use a liquid crystal display. This display is 2 by 16 lengths, thus showing 32 characters maximum. And we need to add some specific statements in the code. The first statement imports the library for the liquid crystal functions. We also need to declare the pins that will be used to connect the liquid crystal. For the device, we need to change the default values to 2, 3, 4, 5, 6, and 7. Also, we have to include the library SDH and set the information and power pins to 8. this pin because if the voltage is increased or decreased, the brightness of the screen will vary. Thus, it is important to keep the voltage constant at 5 volts. The 5-volt pin is directly connected to these two pins labeled VCC and the positive LED. And afterwards, we use one of the ground pins to connect the LCD. We connect it directly to these three pins labeled VSS, R-W, and the negative LED. And we need to connect this other pin labeled BD to the same ground pin using a resistor. This resistor regulates the brightness of the screen. We suggest the use of a 1.6 kilo ohm resistance to simplify the design. As can be seen, the negative pins are at the edges of the liquid crystal display, and adjacent to them are the positive pins. The resistor is attached to the third pin from left to right, and therefore use the pins. We will now connect the Arduino directly to the liquid crystal display in the exact same order that we stated in the code, starting from left to right with pin number 2, pin 3, 4, 5, 6, and 7. And this is how the connection between the display and the micro SD shield is made. Now we have to connect the buttons needed to record behavior. Because almost all the digital pins are used, we have to use the analog pins in order to record behavior. While analog pins allows using variable resistance for the recording, we use them in conjunction with a push button. This button reads digital values of occurrence or not occurrence of behavior. We need to add a 10 kilo ohm resistance between the push button and the ground in order to get a steady reading. Then